Can you guys see the screen? Okay, so I hope you guys have at least revised these chapters, but still let us start with a fairly easy question, I would say. So I just want you all to try to read this question and try to solve it, basically. So I'm just going to guide you guys through. Can you guys see what I have written? I don't think you can, right? Okay, maybe now you can. Yeah. So let us solve this question 5.2. Who amongst here would want to read this question? Mahir, can you read the question for us?
Yes, ma'am. Markov-Chubb process is used to model sickness and death. 4 states are included, namely H, S1, S2, and D, which represents healthy, sick, terminally sick, and dead respectively. We are told that the people who are terminally sick never recover and die at a rate of 1.03 into 1.01 raised to T, where T is their age in numbers. Age in years. Calculate the probability that a terminally sick 50-year-old dies within a year.
Okay, so what do you guys think is the first thing that I should be doing here to figure out this probability?
Ma'am, we can figure out the probability that the person stays in terminally sick state for 50 when for 1 year, and then 1 minus that probability.
Yeah, right, because there's no ways it can go anywhere else once that guy is terminally ill. So does everyone understand that?
Yes,
So
ma'am.
Sauri, can you tell me what should I write here to figure the probability that is? Yeah.
Ma'am, probability S2 bar equal to 50-51 from 50.
Exactly right. So we do care about the times. So I should write 50-51. Yes.
That would be equal to exponent e raised to minus integration from 50 to 51.
Yes.
Then 1.03 into 1.01 raised to t.
Exactly right. So this is the force of transition out of the S2 state. So this is just 1.03, 1.01 raised to t dt. Right? And this is just some constant, and this is a raised to t sort of thing where you are differentiating with respect to t, which is in the power here. So I guess we did a similar thing yesterday as well, while I was deriving the formula of TPX for Gompers. So just for a bit more clarity for people who might not be aware of how to figure these integrations. So integration of a raised to x dx. If I have something like this, what I will do is I will rewrite a raised to x as e raised to log of a raised to x. So I know this a and log will cancel each other out, and I'll be left with a raised to x. So I can rewrite a raised to x in such a manner, which can also be written as e raised to x times log of a. So what I do is I will use this to rewrite this particular integral. So I'll have integration of e raised to x log of a dx. So now as we know, the rules of integration for e raised to x is just e raised to the same thing, and in denominator I have a differentiation of this guy with respect to x, and if you do this, what you get is just log of a. So this is what you will get for this particular guy, and now I know that e raised to x log of a is nothing but what I started off with. So this is nothing but the function itself divided by log of a. So that is something that you will have to use to figure this integral. So I hope this makes sense. And if you try to solve for that integral, you will get some answer. And then to figure out the probability that you will die within the year, then that would just be 1 minus the probability that you stayed terminally ill for that particular year. because once you're terminally ill, you can only be dead or be terminally ill the next year itself. So, well, I guess this is good. Okay, so let us try to do one question where we will actually derive some stuff that we studied. So I'm not going to take this model into consideration. Like, we have done so many stuff with this model, as this did. And what is this? This is a 3-state. So they've given us the transition rates and the distribution. Okay, this is fairly easy. You just have to multiply this. Maybe what we can do is just directly go through the exam style questions. Yeah, this is a bit again healthy sick grade. I don't know how to do this. Okay, yeah, let's do this question, I guess. Yeah, so maybe we should do this question. And so let me just summarize this. So we have a healthy state, then we have temporarily sick or disabled, and then there is a permanently sick or disabled, and then state 4 is that. So this is like, terminally ill, the state sort of something. All right, so there are transitions. And what we want to do is, let us try to do the first question. So they are saying that the transition rates are denoted by mu xij. Is that x? Wait, let me just check. Yeah, so this is mu xij, and then for the probability of transition, you have tpxij. So again, x and t here represent the ages. So x will represent the age, and t again is some difference between the ages. So when I'm saying tpx, I mean that I have observed something at x, and then I'm observing the next thing at x plus t years. So I guess that is what it is. And now the question asks us to derive from first principles a differential equation for TPX 23. So the probability that you will find yourself in state 2 when you are aged X, and that you will have transitioned to state 3 by the time you age X plus T. So this is what we want to figure out. And again, yeah, so they haven't given us any assumptions that we might have to require to figure out this differential equation. So concerning the kind of papers that you will be getting this time, you won't have to specifically derive. Maybe they'll just give you MCQ with some 4 options, and then you'll just have to pick one of the equations, which would be the correct one for this guy. So let us try to solve for this. I think this is a very interesting question. So how will you go about solving this? So for now, let us forget that this is MCQ. We will try to derive it. So, okay. Again, I mean, we don't have to do the full derivation. We can also try to use some logic and what we think is never going to happen, because we know that if I go from healthy to dead, there's no way I can come back from dead to being in state 3 once again, which is permanently sick or disabled. So what will we do in this particular case? What do you guys think I should start with? Anyone?
Can you take the forward differential equation into consideration?
All right. Okay, so we have decided that we are going to go with forward equation. Okay. What else? So if you look at the formula of the forward differential equation, what do you think I should write? So forget this first principles. I guess they have done it using first principles. We can let us try to do it directly using the formula of the Kolmogov's forward differential equation. So I mean, first principles, you can check the answer at the back, but we'll try to directly come up with the answer in 1 or 2 steps max. So can someone just dictate to me what is the formula for Kolmogov's forward differential equation with respect to the probability that we have to figure out? Anyone? So I'm just asking for the formula. No any derivation or something. Just the formula for the Kolmogov's forward differential equation. If we want to figure out this probability.
Would it be like summation over k?
Will it be? Okay, so let us try to write. So first of all, I want to know what is it that I'm trying to figure out. What should I write on the left-hand side?
d by dt TPX.
Yes. I don't want it in terms of, okay, yeah, TPX, fine. TPX 2, 3. All right. Okay. So again, one thing, I guess when we studied Kolmogorov forward differential equations, we used something like this, right? Pijs comma t. So always try to be consistent with the notations that they have given to you in the question. So every time you write this, you can just, make it consistent. Okay. Very good, Vanshita. What will this be equal to?
Summation over a value k.
Yes.
P of 2k in bracket x at time x.
Wait. What? P of 2k. So 2k.
Yeah.
And what should be the time? X. Here I am starting at x, right? And what should I have here?
X to x plus t.
X to x. So should I write x plus t here?
No, t.
Exactly. Very good. Then what will this be multiplied to?
Mu of k2 3.
And when is it that I'm making the jump? At time?
X plus t.
Perfect, right? So I'm making this jump at time x plus t. All right. So I guess this is what we have. Okay. So now what are the values that my k can take?
Can either be state, like state 2 and state 1. 2 and 1. It can be.
It can take 1, 2. Does everyone agree with what I've written on the board here?
It can also take 3, right?
Okay. Vanshita, what do you have to say about that? You didn't mention 3.
Oh yeah, it can take 3.
Okay. We can go to 3 as well, right?
Ma'am,
And
how can it take 2 itself?
How can it take to itself? Why can't it take to itself?
So,
Vanshita, you included 2, right? So I guess, yeah, go on, Isha, sorry. Go on.
so like if we are saying 2, 2, then are we just assuming that it is staying in that state for that while?
Yes. So again, remember, whenever I'm talking about this thing, what I care about is just the fact that I find myself in state 2 in time when I measured x, and when I measured x plus t, I see myself in state 3. That is all. Anything can happen in between. I can stay in state 2 for this much of time till t, and then suddenly I'm moving to becoming permanently sick. Or I might move around a bit and then land up here. So it doesn't quite matter much, right? Does this make sense?
Yes, right.
So I am not saying that I will be in state 2 throughout, because that is not what I want to figure out. I'm just saying that up until time t, I will stay. There is a possibility that I will just be, temporarily sick, and then at time x plus t, I become permanently sick. So that will satisfy one of the conditions that we have. All right. So 1, 2, 3, and I mean k can ideally take on value 4 as well, but then this mu of, okay, what happened? Oh God. Okay, I guess some internet connection, and I have lost everything that I wrote. So, okay, that's a disadvantage. Let me try to do something else. Okay. All right, so I have lost what I wrote. Some internet connection issue, but now that we are back, what I was saying is, I'll have to write that again, right? Just do it quickly. Okay, I'm not going to write it again. Okay, can someone dictate to me what we wrote? It was d by dt px to 3 is equal to summation k pxt to k, and then from k to whatever 3 mu at x plus t. All right, so this is what we had, and we know that k can take 1 to 3 and 4 as well, but mu of 4 to 3 is 0 anyways. So we don't include 4 when we try to expand this. So anytime when you write your answer, you can, just for the sake of completeness, you can mention why you haven't taken the value of k as 4. Because sometimes, let's say if it is not such an easy example as this, and if it were possible and if you missed out, then the examiner will know why is it the case that you haven't included a particular state as the intermediate state. Okay, so I don't know, but if you'll have an opportunity to explain that. Okay, so now what you will do is you will just try to expand this particular thing, and what you will get is tpx from 2 to 1 mu of x plus t 1 to 3 plus tpx. Now we'll take 2, so you remain in 2, and then you transition from 2 to 3. And the next thing we have is tpx from 2 to 3, and then we have mu x plus t from 3 to 3 itself. All right, so this is what you have. So this is one way to write this differential equation. But if you have a closer look at the answer back, this wouldn't quite match. So the only thing that you see might be differing is this particular term here and this particular plus here. Why? Because again, normally we are not given the transition rates for the same state. So generally in the question or even in the actual times, in the reality, what we know is what is the chance of transitioning from one state to the another state. So if you were to rewrite this particular thing, you know that once you are permanently sick, there's no way you can be healthy or be temporarily sick. So the only thing that can happen to you is that you will be dead. But we don't know how soon that's going to happen. So irrespective of the times, what we know is that for each of these times, I know that my mu 3 to 3 x plus mu 3 to 4x. So now this could be x plus t because we have x plus t here. And this is equal to what? What do you guys think should the addition of these would be? So maybe for the sake of completeness, I can also include, from 3 to 2 and then from 3 to 1. So what I'm in essence doing is I'm adding up the third row of my generator matrix. And I know that this is 0. This is also 0, right? But I don't know this and I don't know this either. But I do know that the addition of any row in my generator matrix is 0. So what do I know about this guy? That my mu 33 x plus t is nothing but minus of mu x plus t 3 to 4. So you can substitute this mu 33 x plus t with this and it will satisfy the equation that they have given as the answer in the back. Any doubts with this? Okay, so we did this first part. All right. So let us try to do the second part of the equation. I don't know what this is. Okay, so this is, they've given us some numbers now and we just have to figure out this thing. So we have just tried to write a differential equation, but that was for 2 to 3 and now we have to look at 1 to 3. But I guess they have given some numbers that you might require to use. So I would want you all to just try this on your own now and just let me know if you have any doubts. Or maybe we can try to do this on the board. Okay, let's just do it on the board. I'll write it. No worries. Okay, so let us say I want to do this sum. And first, so the very first thing that we should do is rewrite a differential equation for this guy. Do you guys agree with that? Should we write a differential equation for this guy?
No, ma'am, there is no need. We can split it, right? In terms
Exactly,
of,
right? We can just work with the probabilities because they have given us all the probabilities. We have no idea about the transition rates. Perfect, Minnie. Thank you very much. So how do you think I should split this thing up? So again, remember, we will have to use the information that they have given to us here. So let us just try to highlight in this. So we know all of these probabilities. So what do you think I should do next?
Consider all the probabilities that we can go from 1 to 3 in like 2 times.
So probability that I can go from 1 to 3 in 2 time steps. I mean, that is what I have to calculate, right? If I'm aged 40 today.
Yeah, so
Is,
like we can go from like 1 to 1 and then 1 to 3 or 1 to 2 and
exactly.
3.
Right. So what I will do is I'll just sum it up across for all the possible intermediate states that there can be. But now I want something else. So again, I know this is going to be from 1 to k, and then I'll have p from k to 3. But I want to know the times and times. So what do you think should be the times here?
For first, it would be 40 and then 41.
Exactly right. So why do we have 40 and 41 respectively? So because this takes into account from 40 to 41, and this will take into account from 40 to 41 to 42, which is precisely what you get after this thing. And again, remember why did we not take something like from 40 to let's say 0.5 here, and then 40.5 to let's say, so here you would have 1.5. Why can't we do that? Because we aren't given that information. All the information that we have is for the 1 year, is the annual rates, annual probabilities are being given to us. So it's better for us to just split it that way. So that is what we do. And then what we'll basically do is we'll try to figure out all the values that this K guy can take. So let us try to do that. And so 1P40, 11, 1P41, 13 plus 1P40, 1 will remain constant and this K will become 2 now. And so I'm just going to ignore this one because even if I don't write it stays the same. So P40, 1 to 3 times P41, 3 to 3. Let me know if I make a mistake here, okay? 41 to 4 and then P41, 4 to 3. So we know this doesn't hold anything, right? Because 4 to 3 is just 0. Okay, so we know we have this term, and this term which are non-zero, and the terms that are actually of importance to us. So let us see what are we given. We know the value of this guy, 1, 2, yes, 2, 3, this, yes, 1 to 3, yes, 3 to 3, we don't know, right? Are we given the value of 3 to 3? No. And 1 to 3, we know, yes. Okay, so we aren't given the values of 1 to 1 and 3 to 3. So what do you guys think we should do to figure out these values? The rest of the values we know and these are given to us here. But what about these two values?
Horizontal summation is 1, so 1 minus the summation of the two.
Exactly, right?
Whatever you
So
think.
I know for sure that my 1P40 11 plus 1P40 12 plus 1P40 13 plus 1P40 14 is equal to 1, because there is only possibility that I can go in each of these, in either of these 4 states from state 1. So this probabilities, if I add up, should ideally be 1. So if I know 1, 2, 1, 3 and 1, 4, then I can easily figure out 1, 1 by subtracting this 3 from this 1. And the same you will do for P4133 as well. Okay, this is good. So that's all for the second part. I'm not going to try to solve it, but these values you can easily substitute, and this you can figure out and then just substitute to figure out this particular probability. All right, moving on to next part. Okay, this is some big paragraph. Who would like to read this? Isha, can you read this for us?
The third part.
Yeah, this.
An insurance company issues a combined sickness, disability, and assurance contract that provides the following benefits: an income payable while the policyholder is temporarily sick or disabled, and a lump sum payment either on becoming permanently sick or disabled or on death. The contract terminates as soon as the lump sum has been paid. Explain how the model could be simplified for the purpose of modeling the claims process involved. State how your answer to 1 would be altered as a result of this change.
Okay, so I want you all to take some time to again reread the question if you feel like, and think about what they are trying to ask us. So what is the thing that will be changed now when we try to model this process?
And can we say that the transition from stage 3 to 4 won't be important anymore?
And why do you think so, Isha?
Because if we are looking from the perspective of paying out the claims, then if we are paying the claims when the person reaches stage 3, that is the permanently sick or disabled, that is where the company's job is done, right? That is where the contract terminates. So they are not concerned with whether the person is alive or dead after that. So I think
Exactly.
that one transition will be pointless.
Right. So see, because again, as you rightly said, very good, Isha. So that is precisely what is the one thing that's going to change here. Because now it doesn't matter if you go from 3 to 4, because I mean the company's job would be done as soon as you reach either 3 or 4. So the transition from 3 to 4 is not taken into account from the company's perspective anymore. So now how does this change your answer to the very first part? So I guess even I don't remember what we did in the first part. Let us try to just look at the answer. Okay, yeah. So they've done some derivation, which I think you will understand if you try to go through. If you don't, just let me know. But yeah, the answer is the same. Okay, so how do you think this answer will change now? Anyone?
The last term won't matter
Why?
because, as Isha said, like the transition from 3 to 4 doesn't matter now. That's the reason why.
Right. So we can, yeah, I mean, the transition will just not happen from the company's perspective. So we don't need to account for that. So 3 to 4 arrow won't exist anymore. And that is why that mu x plus t34, it doesn't, it doesn't suit our purposes anymore. So the only terms that we will be left with for this differential equation is the first term and the second term. So yeah, that's it for this particular question. And any doubt, anyone with this? Let me just read. They have a big paragraph. Oh yeah, even they are saying the same thing. Yeah. All right. Any more questions? Any doubts? And then we can just move forward to chapter number 6. And let us first try 6.1, I would say. So again, with this chapter, so yeah, with chapter number 6, I think because we have just recently done it yesterday, I think it's helpful if you just keep the notes very handy, because it does involve quite a bit of formulas and so much of things depending in relationships between force of mortality, the transition rate, and the probabilities. Okay, but again, so coming back to this 6.1, what formula do you think I can use here? So one thing that you can do is maybe have a look at the summary at the end of the chapter from the PDF, or have a look at the flip chart that we made in the class. And check what is it that I can do to figure out 5p60. So the probability that I am alive at 60, but I'll be dead within the next 5 years.
And we can use e raised to minus integration from for 60 to 50 65 and mu x.
Okay, let me just write what you say. Okay, So what should I write here? E
1
raised to
minus,
minus
no, first 1 minus, no, for 5q 60.
1 minus, right? Alright, so what we are essentially trying to do is we rewrite this thing as 1 minus 5 P60 because we
Yes,
know
ma'am.
the occupancy probability formula is very easy, right? So this is going to be 1 minus e raised to,
Minus 60 to 65
yes,
mu x dx. Then we will substitute the mu x.
exactly. And then I guess you all can figure out the integral here. This is going to be fairly easy, right? Is there anything else that you need to take care of? All right. So this is it. This will give you the answer. So what you'll have to do is,
But in the formula they have given, like for TPX it's e raised to minus 0 to t, like the limits are 0 to t.
oh yeah,
So
very good point, Isha. So whenever you have limits from 0 to t, okay, so maybe I can just do the same thing here. Let me just, so you can actually rewrite this same equation in another manner as well. So this will be integration of minus. So again here, if I take it from 0 to t, so my t is 5 here, right? So instead of just mu x, what I will have is this 60 plus x dx. So if you change these limits from 0 to t, you will have here mu x plus t dt, right? And if you take the normal thing that we study, you will have intuitively from 60 to 65 mu x. So both of these are correct and they will give you the same answer. So if you see, the only thing that changes here is this particular term, right? Because this mu x, I mean this, and this is just constant. So if you have mu x, you get x minus 70. But if you have mu of 60 plus x, what you will have is 60 plus x minus 70. So what you get here is x minus 10. And now if you substitute these limits, so let's say if you substitute 60, what you get here is something like minus 10. And if you substitute 0 here, you get minus 10. And if you substitute 65 here, you get the same answer as the one that you will get if you substitute 5 over here. So these are both similar things, similar formulas that you can use to figure out this particular probability. Does this clarify things up a bit? Nisha, I'm here. Does this make sense to you
ma'am,
guys?
can you write the
Yes,
formula
ma'am.
that Mihir also told?
Yeah, it is here in the red. It is here in the red. Maybe what I should just do is maybe I can just write this thing as x minus 70. So I'm rewriting what you will have for this guys here. And so now let me just do something. So if I substitute the upper limit, so let's say I'm going to do that here. So if I substitute the upper limit 65, what I get is 65 minus 70 minus 5, right? For this particular term. And if I substitute 60, 60 minus 70 is minus 10. And now if I do the same thing here, but now I'll have to substitute 0 and 5 because these are the limits. So if I substitute my upper limit first, 5, I get minus 5. And if I substitute 0, I get minus 10. So you essentially get the same stuff. So the actual answer for your integral is not going to change. So if you see x goes from 60 to 65 and 60 plus x goes from 0 to 5. So if I have 60 plus x, this x is changing from 0 to 5. So in a way, I'm just changing myself from 60 to 65, right? Because if I'm adding some x here, this is nothing but 60 to 65 for the whole mu guy. So 60 plus 0 is 60 and 60 plus 5 is 65. So you are taking mu from 60 to 65, which is the same thing that you do here if you are changing x from 60 to 65. You can take your time. Isha?
Yes, ma'am.
Do you understand this?
Yes, ma'am, I got it.
You got it right. Okay, so does anyone have any doubts with whatever we have done so far?
No.
Okay, what about others?
Okay.
Savri?
No, ma'am.
Okay, perfect. So let us try to move on and we'll try to do some more questions. Yeah, okay, this is an MCQ, right? Okay, just try to guess which one of these is correct expression to figure out the current expectation of life aged exactly X. Okay, I think this is fairly easy. Is 1, 2, or 3? Which one of these
Second
is
one,
correct?
right?
First one is correct.
First one.
Okay, so Isha says second one. Isha, why do you think second one is correct?
Ma'am, I thought the K into KPX thing, like we take like expectation of X is X into F of X, right?
Yes, and is this my f of X? Check it once again in your notes.
No, ma'am, the first one only.
Right? It is the first one. So again, there are some issues with the second one and third one, and this is the only one. So yeah, this was easy. All right. But again, we should be careful before jumping to conclusions. Wait. Okay, these questions I'm not going to solve here because I think if they're giving you one mu x and another mu x, then it's just like solving two simultaneous equations to figure out the value of B and C. Maybe we can try to let us try to do this 6.4. This will develop a bit. Okay, so 6.4. We want to express Q30, E30, which is the current expectation of life, and 5P35 in terms of probabilities of the random variable K30. Okay, so can anyone remind me? Yeah, they've said, which represents the current future lifetime of a life, aged exactly 30. All right. So how can I rewrite these three in terms of K30? What does Q30 represent in words? Vanshita, can you tell me what does Q30 represent in words?
A life which is aged 30 right now would die in 1 year.
Exactly right. It will die in a year. Okay, very good. And what does my K30 represent? Isha, what does my K30 represent in words?
The absolute value of the future lifetime.
Right. The absolute value of the future lifetime of what? So I have K30, right?
Of a
Does
person
30 have
aged 30.
exactly right? So the person is aged 30 today. Okay. So Savri, what do you think I can do? I mean, if I know that I want this person to be dead within the next year, what is the future lifetime of this person? What is the value for my K30 that I should have?
No, it will be probability of K30 equal to 0, right?
Yeah, because we know that this life won't get to have something like K31. Because by the time this person becomes 31-year old, this person has to be dead if I want to figure out Q30. right? So this is the probability that we are trying to figure out. So Q30 is just going to be equal to the probability that your K30 will take a value of 0, which means that the future lifetime of this life is 0, right? Because 30 is the last age that he gets to see. At least there's no next integer age that he will see himself alive at. Okay, good. And so now what about E30? What does my E30 represent in words, Mihir?
E30 is just the expectation of that courted future lifetime.
Exactly, right? So it will just be expectation of K30. So E30
Yes.
will just be expectation of K30. Very good. And again, back to Vanshita. What does 5P35 mean in terms of words? And how does this relate to K30? Both questions for you.
P35 means that a person who is aged 35 right now will live for at least 5 more years. So the like K30 should be greater than equal to 5 maybe.
So, okay, K30 should be greater than or equal to 5. That is,
No. K30 should be okay. So person will live for 40 years. So
yes,
T should be greater than equal to 10. But then provided that it should also live till 35.
exactly right. So, K should be greater than or equal to
5.
5. Precisely. Okay. So again, this was very tough, very good. Well done, Vanshita. So the thing that's happening here is, first we have to notice that here I'm assuming that the person is alive till 35 years of age. So the thing I have here is K30. So I only know that the person here is alive till 30. So I have to keep this person alive till 35 years of age. It's as if you're planning a murder or something, you know. I have to keep this person alive till he reaches 35. And then I have to make this person again be alive for the next 5 years. So again, if you see, the total change is of 10 years. We want this person to be alive for at least 10 years. So here I should have K30, right? Does this make sense? Should I write K30 down there? Or is it okay if I just write K there? What do you guys think? Because if I just write a simple K, it doesn't tell me anything, right? I mean, K greater than or equal to 10, ideally, I mean, if I just assume that if I don't write any subscript, it might just mean 1, then I'm seeing that this person is aged 1 and future lifetime of 10 years. So basically till 11. So that shouldn't happen. So you should always remember to write the subscripts. So K greater than or equal to 10, let's say, and you should have these subscripts here as well. Okay, and the similar subscripts you want to keep here as well. So K30 should be greater than or equal to 5, and this information is given to us. And what we want to figure out is the chance that he will live up to 40. And this is the random variable, and 40 minus 30 is 10. So we want this guy's future lifetime to exceed 10 for sure. So yes, this is what you will have. Okay. Any doubts in this? Anyone? I think this was a good question. All right. Calculate the exact values of complete and clotted expectation of life for a newborn animal. Okay, let's just try to do this as well. Just for a bit of a practice. How will you guys try to solve this? 6.5 here. So now we know the force of mortality is constant. This has made our life already easy, right? If it doesn't depend on the years or anything. So this is just constant. And we want to calculate the exact values of the complete and current expectation of life for a newborn animal. So we know we are starting from 0 again. So first, let us try to do this, the complete one. So complete expectation of life is denoted by something like this. And what is its formula? Anyone? What is the formula for 40 days?
Integration 0 to infinity in TPS dt.
Integration 0 to infinity tpx,
dt.
right? And so what should I have here? Now, first of all, do I know my x here?
It will be 0.
Right? So this ex0 can be written as e0, 0, because I'm talking about a newborn animal, right? So that guy, that animal is 0 years age, and so you'll have tp0 dt. And how will you solve for this? What is the value of tp0?
P raised to minus mu t.
Exactly right. So it is again similar to the occupancy probability, and with mu being constant, which is 0.05, this is just e raised to minus mu t dt. And now I'm not going to solve this, and I guess so. One thing that, why did I write t here? Yeah, it shouldn't be t. This is infinity.
Ma'am,
All
it
right,
is
yeah.
e raised to minus that integral, right?
Yeah, okay, very good thing, Isha. Okay, so let us try to solve that integral and let's see what do we get. So it is e raised to minus 0 to t 0.05 dt, and let's just write ds because we have a t here. All right, so what we will get here is 0.05 s, and this will go from 0 to t. So if you solve for this, you get minus 0.05 t, because this 0 when gets multiplied, it's just going to be 0. So whenever you start from 0, you know the other term vanishes. So that so you can easily rewrite your occupancy probability as just e raised to minus mu t. Does this make sense, Isha? A very good question.
Ma'am, I didn't understand how, like, why can we also write it as integral 0 to infinity and that part?
Oh, why can we also write it as 0 to infinity? Okay, so ideally we know that the maximum age that any person or any animal, let's say, can attain is omega, right? After that, the chance of surviving itself is 0. So let us say what we are doing is, maybe I don't want to do it very mechanically. The thing that we are, let me just erase all of this. Okay, so is this clear to everyone? I'm going to see this, and okay, what's happening now? Okay, yeah, and let me just clear all of this. So again, very good, Disha. So what I am trying to do is, let us say I have this graph here, and this is the graph, and over here, this is 0, okay? This is 0. So if I'm starting at 0, and the maximum age any person can attain is omega, right? And if I try to add up the area under the curve till infinity, it will be same as the area under the curve from 0 to omega, right, Isha? Because over here, the area is just 0. So
Yes,
it
ma'am.
doesn't matter if I add from 0 to infinity or from, I guess this is very good. So does this clear things up a bit? So what happens is, your TPX after this omega is 0. So you have
Yes,
no
ma'am, that
area
part
to,
I got, but like, why can we also write it with the integral outside of t?
integral outside of T.
Because what you had written was integral 0 to infinity e raised to uh, mu t, I think.
Wait, we'll see what did I write over here. It should be the latest one. Okay, let me just new share. This is what I wrote, right?
Can't see the screen, ma'am.
Can't see it. Now, can you see it?
Yeah. Now,
Okay.
so the right bottom part, why can we write the integral outside of E is what I'm saying.
This?
Yes, ma'am.
Because it is the expected value.
Okay, Vanshita, do you want to try to explain that to her? Go on.
Yeah, I just said, yeah, because it is the expected value, so we consider it as each and every instance from 0 to infinity.
Does this answer your doubt, Isha? Is that what you were trying to ask?
So it is similar to the thing that you said, the area under the curve part.
Okay, no, the area under the curve part explains you why don't we have this integral going from 0 till only omega. And I suppose your doubt is, why do we have this integration outside and this e inside? So to answer that, my integrand here is tp0, right? And I can rewrite this tp0 as e raised to minus 0.05t, which I have derived here, right? So I'm doing nothing but just substituting for this guy over here. So this E and this E has no connection. This is just a representation of the expectation, right? And this E is the normal E that we have, the number E.
Okay, got it.
And this integration is again from the formula. So as Vanshita said, we have this integration because we want to take into account all the different possibilities of this P guy. Clear?
Yes, ma'am, got it.
Okay, very good, very good. All right. Now how do I close this? All right. All right. So I guess this was a healthy discussion. And now let us try to do this. 6.6 is also a good question. Let us try to do this question. Yeah, so I want you all to just read this on your own and then just tell me if you know what should I do. It's a very funny name, right? Very Ruthless Management Consultancy Company. As if the ruthless wasn't enough. Very ruthless.
Ma'am, so we have to find out the coordinate expectation, right?
Yes, good. But one question I would like to ask you guys is, what does this duration represent here? What does this duration represent? Is this like the future expected lifetime of people or something else?
The number of years the person has successfully completed in the company.
Exactly right. So this duration here does not anymore represent the future lifetime of a person, but it represents the future lifetime of a person that this particular person spends working for this particular ruthless company. Okay, good. Okay, so we want to figure out quoted expectation. Isha, can you tell me what should I do next? Formula or something that I should do?
So we have to find out since the person has joined, right? So it will be from E0 itself.
Okay. So what should I do next? And okay, so what do you mean by it will be from E0? If I'm talking about current expectation, okay,
So we
you mean
have
this.
EX. So EX will be like that person is X aged right now, but here we are considering it in terms of duration, and we'll consider that from the start itself, right?
Okay, yes, fine.
So that is why E0.
Okay. What should I do next? This is very good. Oh, why written EX? It should be E0. Yes. What is the formula for E0, Isha?
So it will be the formula for EX is summation K equal to 1 to omega minus K kpx. So if we link it to E0, it will like just the kpx will be replaced by kp0.
Exactly right. Okay, and again, can I change this W minus K to something that I know?
To
What is the
9.
maximum? To 9. Okay, yes. So my K can take values up until 9. So I can easily replace this and just write here 9. All right. So now what I'm doing is 1P0 plus 2P0 and so on and so forth till 9P0. Okay. So now we want to figure out the values of each of these guys. So Savri, can you tell me what will be the value of 1P0?
It will
Okay.
be
Maybe
70.
forget. Okay. So just tell me how can I rewrite KP0? So for any K, let's just generalize it.
KP0 will be LK LK plus upon L0.
LK upon L0. Yeah. So again, I think, I mean, that was a very direct answer, I would say. So when I'm talking about KP0, what I mean is that I'm actually looking at the survival for a guy aged 0 to live for next K years with the company, right? So I can just rewrite this thing as S of K upon S of 0 as well. So you can also use this, or you can directly use this formula. This is pretty straightforward. So every time what you'll be doing is just for 1P0, you will have 72 upon 1 lakhs, then 51 upon this, and so on and so forth. And you just add all of them up and you will get your answer. Does this make sense? And this S of K will directly be, just this 72, and this S of 0 we know is 1 lakh. So you can do that as well. Any of these methods. Perfect. Any doubts with this question? No? All right. So let us try to move to some next question. This we have easily figured out, I guess. This is a theory question. Let's try to do 6.9. Yeah, I think this is a very good question. 6.9. So if we look at the question, here the force of mortality is not constant anymore. So you see the force of mortality changes depending on the ages. So if you are aged from 60 to 70, so if you are aged 70 as well, this is your mortality rate. And from 70 to 80, this, and more than 80, this. And now we want to figure out the probability that a life aged 65 will die. Okay, so not this. Life aged 65 will die between exact ages 80 and 83. So this is good. Okay, so now can you tell me how will I write this thing in terms of TPX and all that stuff, basically? What will be my notation to denote this particular thing? So we studied something called, deferred thing, and you'll try to use that. So go back and have a look at the criteria expectation when we try to derive the formula for probability that it will take some number small k. We have used something that will help us to write this particular probability. So tell me, what is it that I can use here?
It will be just 15p65 into 3q80.
It will just be 15p65 into 3q18.
3q.
Yeah, right. This is actually correct. Very good. So again, we only want this person to be alive till 80 for sure, and then you can die anytime in between 80 and 83. So this is precisely what you will have to calculate. Very good, Mihir. And how should I go about calculating that? Do I know 15p65?
We will have to divide 15p65.
Yeah. And how should we divide that?
It will be 5p60 into 10p70.
Okay, wait. Let me just write. 15p65 will be equal to
5p60 of 5p65
Very good.
into 10p70.
Precisely right. So this is what you will have. So this is just the consistency condition that from 65 to 80, you can divide it in some interval and then just multiply them together. All right. So now you can figure out 5p65 using this mortality rate. And now this is just constant, right? From 60 to 70, this is just one constant. So Isha, can you tell me how should I write this 5p65 using this mortality rate?
So will it be using the E thing?
Yes.
So it can be written as E raised to, just a minute. E raised to e raised to minus 0.01 t.
Yes. Do I know the value of t here for 5p65?
It will be 65, right? No, it will be 5.
Exactly right. It will just be 5. Very good. You got this, Isha. So perfect. And similar, you can do this for this guy as well. E raised to minus mu is 0.015 and my t is 10. All right. So that is how you will figure out the first probability. And then you will have to figure out the Q thing, right? So 3Q80. How will you figure this out?
One minus 3p80.
Exactly right. 1 minus 3p80. So remember, it's always much easier to figure out the p. So whenever you have to figure out q, just write it as 1 minus p, and you can figure out this thing using the similar stuff. All right. So I guess this is all we had to calculate. But again, just to give you guys remembrance of some concept that we studied, the whole thing that we have here can actually be written as Q 65. So I know that I'm aged at exactly 65. And now if you go to page number 15 of this chapter, you see that we studied something called K bar QX, right? Which we call as K deferred QX. So this means that I cannot allow this person to die for the next K years. And then this person can die in the next year. So here we don't have only 1 year, we have 80 to 83. So this person can die in the next 3 years, but this person should not die in the next 15 years. This person can only die in the next 3 years after these 15 years, after this 65. So this is the probability that we have calculated, which is 15p65 times 3q80. So just this notation we will try to remember. All right, so I guess that was it. And now let us try to do 6.10. And yeah, this is the last thing that we'll do today. So do you guys want to do this now, or do you guys want to take this as a homework and maybe just try to do it on your own?
Now,
Okay, let's do it now. So I want you all to read the question and then we'll solve the first part. Meher, can you read the first paragraph?
Yes, ma'am. The mortality of a certain species of furry animal has been studied. It is known that at ages over 5 years, the force of mortality mu is constant, but the variation in mortality with the age below 5 years of age is not understood. Let the proportion of furry animals that survive to exact age 5 years be 5p0. Show that for furry animals that die at ages over 5 years, the average age at death in years is 5 mu plus 1 upon.
Yeah. So, okay. So again, we'll forget that we have to show this. We'll just try to prove this. So we know that the force of mortality mu is just a constant for the furry animal aged above 5 years. And we don't know much about these animals aged below 5 years. The only thing we know is that the proportion of these furry animals that survive till 5 years, so the proportion of animals that we see are alive by 5 years of age is 5p0. All right, so now we have to show, forget show. Now what we have to do is figure out the average age of death for furry animals that die after attaining 5 years of age. Okay, very good question. So how should we do this? How do you guys think I can figure out the average age of death? What should be my very first step here? Anyone? So if I want to figure out the average age of death, what is the precise age that each of these animals is likely to die? How will I measure that age? So I think maybe this is a bit tricky question. So we'll have to think beyond and a bit in creative sense to try to answer this question. So because we haven't yet any time clearly specified a formula for the age at which people particularly die, right? But we have studied some variable. So try to recall all the variables that we have used in this chapter and then try to see which one of those variables we can use to figure out the age at which an animal would die. An animal would die.
Can we calculate the expected lifetime and then we'll just have to add 5 to it?
Exactly. So again, when I'm okay, that was actually, I mean, that is actually what we'll be doing. Very good. But just to explain it again, whenever I'm talking about these animals, and so in my first part, they're asking me that these animals cannot die below 5 years, right? They can die only once and all they attain the age of 5. So I know for sure that these animals are dying after being 5 year old. So I don't care about what was the mortality rate before they attain the age 5. And that is what I do not have any information about. So that's good because I couldn't have anyways done anything to figure that stuff out. So the next thing that I know is the force of mortality after the age of 5 years. So if I know this mu, but again to figure out the age of death, this is a bit tricky. So what I can do is instead of figuring out the actual age of death, what I can do is I can see if I can try to figure the expected lifetime of each of these animals. And the age at which this lifetime ends is the age at which these animals die, right? So, and this whole chapter we studied about the future lifetime. So that is good. And at the end of this chapter, we studied some parametric survival models, wherein we saw that if we assume that the future lifetime follows exponential distribution, then my mortality rate becomes just one constant mu. So here, if I'm given that this force of mortality is just one constant, I can say that my future lifetime will be exponentially distributed. So if you remember, we derived TPX, and that was something like e raised to minus mu t. So I did say that, here instead of the rate of occurrence of something, we are trying to see the rate at which people are bound to die, which is mu, the force of mortality. So here you will say that your future lifetime follows exponential distribution with the parameter mortality, which is just mu here. So once you know that, what you want to do is you want to figure out the average age of death, not the actual age of death, right? So you will look at the expected future lifetime of these animals. And again, we have to remember that we are not looking at these animals when they're aged 0. We know that this mortality rate, which is mu, is only once they have attained the age of 5. So the average future lifetime that we will get is, again, now we know that this guy follows exponential distribution with mu as the parameter. So the expectation of this guy will just be 1 upon mu. So that is how far you would expect these animals to live for on an average. And now again, as we know that this mu was only for after 5 years, and we know that these people, these animals have survived for 5 years. So to figure out the actual average age of death will be to add 5 to it, because expected future lifetime is 1 upon mu, and then you will have to add a 5, because if you want to figure out the actual age that these people are when they die, you will need this 5. So if you do the cross multiplication and stuff, you do get this answer, what they have shown us here. Any doubts? I think this was a really thought-provoking question. Any doubts with the part 1? So you should try to see the chain of thought that we use. So again, whenever we are dealing with a question that directly does not correspond to what we have studied, we should try to think of all the stuff that we have studied. So maybe for this chapter, because now we know that this is from particular chapter number 6, what I did was I'll just recall in my mind all the concepts that I have studied in chapter number 6, and I will see if any one of those will allow me to figure out the stuff that is being asked to me in this question. And if you get such kind of a question in the paper, where you see some term that you have never seen before, you should try to recall chapters one by one and see if any of these fit into the category that fit into the the answer that you want to figure out. So once you decide that, then you can try to see what is the relationship, and then I guess you will have something to start from. Because sometimes what happens is we see a question and we're like, oh, I don't know where to start from. This is something that our teacher has never taught us. This is out of the syllabus. No, it is never out of the syllabus. So I guess this was very good. Okay. Any doubts in the first question? Anyone?
No, ma'am.
Okay. So moving on to the second part. Now, what does the second part say? They are asking us to now figure out expression in terms of mu and 5p0 for the proportion of all furry animals that die between exact ages 10 and 15 years. Okay, again, very good question. And now I just want you all to tell me in terms of, the numbers, and basically what is it that we're calculating here, not in terms of words, but in terms of the notations that we have studied. How can I rewrite this second as? What is it that I am being asked to calculate here?
So, ma'am, it is telling us that that the animal should survive for 10 years first, right? So,
Yes.
10p0 into 5q10.
So 10p0 into 5q10. Okay. But what will this give you? This will give you the.
Yeah.
Okay, no, go on. What will this give you?
So we can write 10p0 in terms of 5p0, right? 5p0 into 5p5.
Yeah.
And then the constant mu is given, so we just have to e raised to minus.
Fine. Yeah, that is very good, very good. But okay, so very good, Mihir, very good. So what does this represent in words now? Can you tell me what does this represent in words?
That the animal will survive till age 10 and will die within next 5 years.
Right. So is this what they're asking us? Try to read the question once again now. So this, the expression that we have written on the board is for one particular animal, right? For that particular animal to survive till 10 years and then die within the next 5 years. But the question is asking us about the proportion of all furry animals that die between the exact ages 10 and 15 years. So this is not only for one particular animal or a particular probability that we are looking for. We are looking for, let's say, the total number of animals that will be dying when they are aged 10 and 15 and in between. So how can we feel? Yes, sorry, go on.
Ma'am, it will be 10P0 minus 15P0.
10P0 minus 15P0. Why do you think it should be 10P0 minus 15P0 and not 15P0 minus 10P0?
And because the number of furry animals that survive till age 10 will be more than those survive till age 15. So
Exactly right. So sometimes what happens is when we see these kind of expressions, we have this idea in mind, right? We can do like 15 is a bigger number, so 15 minus 10. But remember, even though you will not be figuring out the actual answer in this case, let's say for e raised to chi, because we aren't given the value of mu here, so you won't know that the answer that you will be getting is negative, and negative proportion does not exist. So you should, I mean, this is a bit non-intuitive, but you should keep this in mind that always 10P0 is a higher number than 15P0. The probability that these animals will be surviving till age 10 is way much more than the probability that these animals will survive till 15. So what I have to do is 10P0 minus 15P0. And again, why I am writing 10P0? Because they have said in the question that let the proportion of furry animals that survive to age 5 years be 5P0. So ideally, this is just a probability. But for now, they're assuming that this also denotes the proportion. So I mean, ideally it does, right? 0.3 chance of happening is just like 30%. So this is what we are trying to do here. So whatever proportion we will get here, sorry, whatever answer we will get here will be the proportion of furry animals that would have died between these ages. All right, so this is what we will have to figure out. And now, as Mihir rightly said, we can use to figure out this 10P0, 5P0, and then 5P5. And here you will use 5P0 times 10P5. And now, as we know the value of mu, you can easily derive these values. And you can maybe take 5P0 common. But yeah, whatever, you'll get the same answer. Any doubts in this question?
Ma'am, if we solve
Yes.
using the equation what I told, I think we'll
Yeah.
get the same answer.
Oh, you think we'll get the same answer?
Yes, ma'am.
Do you want to did you try that?
Yes, ma'am. Like I'm getting 5p. So suppose if you write 5p5 in terms of mu, it will be e raised to minus 5 mu, right?
Let us try to do that. So, okay. But again, I think, so 10P0 and then 5Q10. So this is saying that we have, but this is, okay, so, okay, yeah. I think it will give you the same answer. Why? Because even though this is for one animal, the total number of animals that we assume here is 1. Because I'm equaling my probability with the proportion. So the
And
total
ma'am, if
number
we
of,
just expand 5Q10, then we can write it as 1 minus 5P10, right? And then if we open up the bracket, it will give us the same answer.
yeah. So yeah, I think so. Again, remember this is going to work only for this particular question because 1 is the total number of animals. I mean, 100%. Yeah, of course. So I think yes, very good, very good. So yes, you can do any of this. Very good. Any more doubts? No, but okay, just give me a minute. Let me think about that. Oh yeah, I think even if this is true only for this particular question because there's a big difference between, the proportion and probability.
Like I think both the formulas that you have written in the green and orange are same, because I think we had some sort of relationship like this in CM1, like same formula.
Oh, I haven't studied CM1, so I don't know that. If you say so, I will just believe you.
Actually, I don't remember well, but I think there was, like, we can write in difference.
Okay. I don't know what you're talking about, but yeah. Okay, all right.
Ma'am, when you said that this is true only for this case, can you please
Yeah.
explain why it would be like the difference between proportion probability? Because just before this term, you can see the last line that calculate the probability that a life aged exactly 65 will die between 80 and 83. We did the same thing.
Yes.
So there it was probability, and here it is proportion. So then what the difference, and like where will be the difference?
Okay. So when I meant proportion, what the difference I see is because here we aren't asked about one particular animal. So if you see the orange part, the way I will interpret this particular thing, oops. So the way I will interpret this particular thing is for one animal, right? I mean, this is for one animal to be alive till 10 and then die in the next 5 years, right? This is what we did in the previous question. And in this question, they're asking us about some number of animals that would have died between this age 10 and 15. So ideally, I see that I want to check how many animals are alive by the 15 and then how many animals are alive by 10 and then maybe kind of subtract that. But that again goes not, I mean, that is what your intuition will tell you to do. But what ideally you should be doing is 10p0 minus 15p0. So here, I mean, because I'm asked about, how many animals died in between this year and that year, for me the very first thing that comes to my mind is that I want to look at some difference, like how many people were alive and then how many people were alive, something of that sort.
Okay, because in my mind also, the first thing that came was what Mihir said. So, I mean, what technically it might not seem correct, but like some wise it gives the same answer, so it will be correct, right?
See, not necessarily. I mean, this could just be a coincidence as well. But again, okay. So again, why is the answer same in this case? Because let me just try to say. So we have,
Even I think it will be same, because even if we try to
yeah.
uh, the difference and derive it further, we get the same answer.
Yeah, so I guess Vanshita again, yeah, sorry, you are actually correct. So whenever I'm talking about proportion, I'm talking about some percentage, right? So the maximum percentage I can have is 100%, and that will be a probability. I mean, corresponding probability would be 1. So for each proportion of, let's say, 65%, let's say, I will have, I mean, 65% if I'm talking about, which will be the, in terms of proportion, 0.65. I can see that 0.65 is also the probability. So, but again, what you should just change is the way you read this particular expression. And this should be in terms of proportion and not only corresponding to one animal. Then I think it's correct. So these terms are correct. This will give you the same answer. But the way we have studied these terms up until now is not how you should have a look at it in this particular scenario, I would say. I don't know if you guys are getting what I'm trying to say, but I think if you do understand this, then it's really nice. And here, if you can, you say that this is something from CM1. If you stumble across it, then just do let me know what thing did you connect this with. But I mean, just the way you interpret that 10p0 times 5q10 should be a bit different than just a probability, I would say. If you, I mean, I guess, but yeah, it says the same thing. So
Yeah, no, but only intention of asking this was because, uh, like, even I thought the thing what Mihir thought, and you told that it might not always hold true. So just like the chance that where I
yeah,
go wrong, so that's why
yeah, that is, I think, yeah, yeah. This is actually a very good question, and it's really nice that you guys thought it in a very different manner. And I think this is really nice. So, but do you still have doubt? So the conclusion, let me just conclude. I said that this might not hold true in every case, so that is wrong. And this will hold true for every case. Whenever, yeah, because if I'm looking at the proportion, I can equate that in a way to probability, and I can interpret this particular probability in terms of proportion as well. So this will give me the same answer. And this will represent two different things that I can imagine in my head, one in terms of probability and other in terms of proportion. Does this make sense?
yes.
Okay, perfect. I think this was really good. I really like such kind of discussions. Okay, so part 2 done, and now going on to the part 3. What is there's some information that they've added. A new investigation of this revealed that 30% of those born survived to exact age 10 years, and 20% of those born survived to exact age 15 years. Okay, so now it seems like they have given us the value of 10p0 and 15p0. So again, this is in terms of proportion. So when they say 30%, it means 0.3, and that also is linked with the probability. So my 10p0 is 0.3, and my 15p0 is 0.2. And if you know that information, what you will have to do is figure out the value of this mu guy and the value of 5p0. So once you figure out mu, I guess you can figure out 5p0. But yeah, I mean, yeah, I guess. So let us try to do this. How do you guys think I should proceed to solve this particular part? So I know the information NP0 is 0.3 and 15p0 is 0.2. How can I figure out my value of mu and 5p0 from here?
We can write both in terms of mu and 5p0, right?
Exactly right. So I think as we've already discussed, 10p0 can be written as 5p0 and 5p5. So I don't know this guy, so 5p0, and this I know has a constant mu. So this will just be e raised to minus mu t instead of t5, right? So e raised to minus mu 5. And similarly, you will have something for this. So you can maybe just denote 5p0 as some let's say some random variable a or alpha, and then you can figure out the value of this alpha and this mu, as this will be two unknowns and two equations. So I guess that is all that you'll have to do for the third part. Any doubt with this? Anyone?
No.
Perfect. So I guess, so again, I mean, you might be tempted to figure out the value of IP0 once you figure out the value of mu. But you should remember, we don't know anything about the force of mortality from 0 to 5 years of age. Mu is just after 5 years of age. So you will get the value of 5P0 directly by solving these simultaneous equations. Okay, so very good. And I guess that's all from my side for today. And I will see you guys day after. Unless you have some doubts or anything else that you might want to ask now. Anyone? Any doubts?